have a big problem. Last night, instead of sleeping, because I do this, I don't sleep, and then the next day I go, oh, I'm super tired. I wish I can get some sleep, and then just that cycle just repeats itself. Hello everyone, today we're going to be upgrading our RNN such that we can train it to be able to output 10 when we feed it a sequence of 2, 4, 6, 8. So essentially what that means is rather than having a many-to-many type of RNN, which is what we've had before with our hello example, we're going to be creating, or we're going to be upgrading our RNN library such that it can also automatically determine and train a many-to-one type sequence. The way I encoded it in Excel that seems to work is just the following. It was just a very simplistic input vector that I added to the network. And, this is time step 1, time step 2, time step 3, time step 4. At time step 4, I wanted it to be able to determine or to be able to figure out the pattern to output 10. For the other time steps, I really didn't care what it outputted. We could either do this one of two ways. First way is we could have a nil in all of these sections. The only problem there is if you have a really, really large sequence that you want to feed into the RNN, that's going to waste a lot of space in memory. This is option number 1, and this is probably the option that I will do first just to ensure things are working. So option number 2 is, let's say we have the same sequence. Instead of having a vector of size 4 as our target, what we're just going to have is we're just going to have the 1. And so the network will just have to be able to just say, if length of x is equal to length of y, or our target, then it's more of a many-to-many. Else, actually, you know what? Because there are other types of recurrent neural network structures, so one-to-many and a many-to-many, which I haven't played around with. Let's just say else if length of y is equal to 1, then you know that that's a many-to-one. Okay, that doesn't seem too difficult. Let's try option 2. Let's just prepare our new inputs up here. So now the only part that won't work is back. So here's what I'm going to do. I'm going to change this line here. This line, it calculates delta output and it calculates the loss, which are the two things that are confusing me. But it also treats targets as if it's a matrix that has the exact same size as input. So input has size 4, it'll treat target as if it has size 4. So what I'll do here is I will say, okay, if target has length 1, which is what we've determined here, then delta outputs will be 0 and loss will also be 0. Which is exactly what we've implemented here in Excel. Actually, you know what? Let me take a step back for simplicity because I think it'll be easier this way. Let's start with this if statement first. So if length of inputs is equal to length of target, then we go ahead and then we set our delta outputs and our new loss accordingly. That's simple enough. Now here's a problem. If length of y is equal to 1 and last time step, then we do this. Actually, you know what? No. Take a step back. If length is 1, that means it's many-to-one. And so now that it's many-to-one, if last time step, then calculate delta output using target, else delta output is equal to 0. And that should be that. We go ahead and we try to run that. We get an error. Of course we do. Over here is where it errored out. And it errored out with the add function, meaning that this here and this here are different sizes. I wonder why. So the input size is 1, 2, 3, 4. Our output size is 1. Still giving me an error. Still in that exact same line, 730. Oh, gotcha. Okay, I see what my mistake is. So we're only inputting one thing now, because remember with hello, we had 4 bits that we were inputting into the network. Now it's just one number. So I just need to update my input size as well. One thing we also need to do is we need to change up our network. So instead of using softmax, this will have to be identity. So what we see is our network has now, well, first of all, it's definitely overtrained, but it seems like it's working. So we have a many-to-one, so many inputs, 2, 4, 6, 8, and then we're just looking for the one output, which is 10. And over the course of time, it's kind of taught itself how to output that. Just making sure that we didn't break anything, though. Let me see if I can you imagine? Can you imagine if those features that I added just completely went and obliterated everything else that we've done before? Oh, I would be so upset. Let's just make sure it didn't change anything. And I'm actually a little nervous. Okay, so yeah, it looks like it's still losses decreasing, weights are updating, and it's still able to output the word hello. Okay, that's all I wanted to double check.